See, then we can say that a of x is equal to b of x if their corresponding coefficients are equal, right? That is if and only if an is equal to bn. That means nth coefficient in the first power series is equal to nth coefficient, I mean x power nth coefficient is bn. Both are equal. For each n greater than or equal to n, then those given series are said to be equal. Multiplication by a scalar. Now when a series is multiplied by a non-zero scalar, c into a of x can be written as summation r running from 0 to infinity c into ar. That means the coefficients in the power series we are multiplying it by c, right? C into ar into x to the power of r. The coefficients of x power r are multiplied by c, non-zero constant. Now sum a of x plus b of x. A of x is a power series, b of x is a power series. If you want to add those two power series, simply we have to add the corresponding coefficients of the power series. That means here summation r running from 0 to infinity ar plus br x to the power of r. Okay, that means constant separately x power coefficient, x power 1 coefficients you have to add, x power x square coefficients you have to add, x cube coefficients, x power 4 coefficients, like this you have to add all the corresponding x power ith coefficients. Product a of x into b of x, product of two formal power series, that is denoted by another series n running from 0 to n pn into x power n, where pn is equal to this thing, summation I plus j is equal to n, where ai into bj. We know a of x, we know b of x, right? If you expand this one you will get. Now if you multiply these two, you will get this type of series. See, a naught b naught plus a naught into b1 plus a1 into b naught into x, a naught b2 plus a1 b1 plus a2 b naught into x square and so on, right? మనం ఇవన్నీ ప్రాబ్లమ్స్లో వస్తాయమ్మా మళ్ళీ. Now next one, for any n belongs to z, you have to remember these formulas. 1 plus x whole power n is equal to this one. 1 plus x whole power n is the generating function for the sequence. That means these are the coefficients, no? ఎప్పుడైనా సరే, what is that? A generating function generates the coefficients of the power series, remember, right? Or generates the terms in the sequence. Now 1 plus x can be written, 1 plus x whole power n can be written as nc0, nc0 into x power 0, nc1 into x power 1, nc2 into x square, nc3 into x cube, so on ncn into x power n. This is another notation, n0, n1x, n2x square, n3x cube, nn x power n. This is another notation, or you can write nc0, nc1, nc2 and so on. Here 1 plus x whole power n is the generating function of the sequence. These are the coefficients, no? nc0, nc1, nc2, ncn and so on. Next terms are zeros, no? That's why I wrote 0 comma 0 comma 0. Now here are again some formulas. 1 plus x whole power n is equal to another notation I told you, no? nc0 plus nc1 x power 1, nc2 x square plus nc3 x cube plus so on ncn x power n. This is another notation. Similarly 1 plus ax whole power n is equal to nc0 plus nc1 ax, nc2 ax whole square plus so on ncn ax whole power n, which can be written as a square x square, a cube x cube and so on if you if you expand it. Similarly 1 plus a x power m whole power n can be written as nc0 plus nc1 x power n plus nc2 x power 2m plus nc3 x power 3m plus so on ncn x power nm. Now 1 minus x is equal to 1 by 1 minus x, 1 by 1 minus x is equal to, you have to remember this formula. All these formulas are important. 1 plus x square plus x cube so on. This can be written as 1 minus x whole to the power of minus 1, no? If you transport this one to numerator, it becomes 1 minus x whole to the power of minus 1, which can be written as summation I running from 0 to infinity xi, right? If you remove the summation again, you will get this series only, right? Now similarly 1 by 1 minus ax formula, same as in this case, 1 minus ax whole power n, 1 plus ax whole square plus ax whole cube and so on. Summation form, shortcut form, summation I running from 0 to infinity ax whole power I. Similarly, 1 by 1 minus x power n is equal to 1 minus x whole power minus n is equal to, we are expanding in the terms of binomial coefficients, minus nc0 plus minus nc1 into minus x plus minus nc2 into minus x square and so on. Right? Again, once again, we wrote the same formula 1 plus x whole power n here. Right? Now here next one is 1 minus x whole power n, 1 minus x whole power n plus 1, 1 minus x whole power n plus 1 by 1 minus x. See here, right? Now here 1 is equal to 1 minus x into, this is 1 minus x. 1 minus x into 1 plus x square plus x cube and so on. 1 by 1 minus x, we are transporting this one to the left hand side. This one we are getting. Simply please go through these formulas. 1 by 1 minus x square, x by 1 minus x square. Similarly 1 minus x power 5 by 1 minus x. This is very important one. 1 plus x square plus x cube plus x to the power of 4 only. Right, up to here. Now x by 1 minus x is equal to this. It is an infinite series. Tomorrow we'll get the sorry, tomorrow in Google Meet class we'll solve the problems based on these formulas. Okay, please note down these notes.